So in this topic, we will need to be basically considering the different types of forces. We've already said what a force is. A force is basically any push or pull. Now, it's important for you to understand kind of the different sort of words we use to describe forces and the different sort of types of forces. And we'll basically be filling in this table as we go. We won't be filling in completely today, but I will sort of want you to sort of understand sort of where we're heading. So we've got different types of forces. For each and every force, I want you to understand and think about, you know, when they apply, like when do we have this force? And if we have this force, importantly, because force is a vector, what is the magnitude of this force, if we can calculate it, as well as the direction of this force. So as we go through more and more forces in the coming weeks, you need to be thinking about, one, what forces do we have? And for every single force, in this situation, do we have it? Based on the condition column. And if we do have it, can we calculate the magnitude? Do we know how big the force is? And do we know what direction it is?
Yes.
Now, the very first force we're going to talk about is one that we've already talked about a few times, and you probably know a fair bit about it. And that is weight. Do you understand what weight is?
Yes.
What is weight?
Like how heavy you are.
So is weight a force or is it not a force?
Yes, of course.
So how heavy you are normally refers to mass, right?
Yes.
So if we're saying weight is a force, what type of force is weight?
The force that like
Actually, weight is simply a special name we use to refer to a gravitational force between like a planet and an object. So it is exactly a gravitational force. Now, since most of the conditions we do, most of the questions we do are on Earth, then basically this is always there. For our purposes, for the questions we're doing, we're just assuming it's always there.
yes.
You'd have to get off Earth to not have, the Earth weight. But we'll assume we're on Earth for now. When you get to year 12, we might do times when we're not on Earth and so on. But for now, everything we assume we're on Earth. Do you know how to calculate the magnitude of weight force?
W equal mg.
That's correct. And what's the direction of the weight force?
Down.
Right. Now, let's talk a little bit more about it, about the sort of formulas we've said. So we said the weight is a force. So what is the unit?
Newton.
Correct. And it's not the same as mass. So weight is the gravitational force due to Earth, if you're on Earth. And it's basically how strongly, therefore, Earth pulls you. Now, this is different to mass, which is measured in what unit?
Kilogram.
And what that represents, in a way, is how much matter is in the object. So recognize that these are two distinctly different concepts, even though they are related to each other. Weight is a force, which is how strongly Earth pulls you down, and mass is just how much matter you've got inside that object. And you are 100% correct when we say that W equals mg. That is the formula. But I also don't want you to just memorize the formula. I want you to think about what this means, because weight is a gravitational force, right?
Yeah.
And m is mass, right? In kilograms. Yeah. What's g?
Gravity.
Well, firstly, do you know what number we use?
On
Earth?
9.8.
Right, so it is equal to 9.8. Do you know what unit it is?
Meter per second.
Right, it's 9.8 meters per second. So what does that remind you of? If it's meters per second. So G is actually, because it's meter per second, and you recognize it's the same unit as acceleration, it's actually the acceleration due to gravity. It's not gravity, it's the acceleration due to gravity. And if we compare against Newton's second law, what's Newton's second law, by the way?
Newton's second law, m equal F equal ma.
So if Newton's second law is F equals ma, and we have F is force, m is mass, and a is acceleration, is there a difference between F equals ma and W equals mg?
No.
Not really. W equals mg is just a very special, it's just substituting weight for the force and g for the acceleration. But basically, it's still F equals ma.
Yeah.
Okay. But yeah, that's your very first force. Our very first force that we're looking at is weight, which is a gravitational force. And simplistically, we'll just say for now on Earth. To calculate it, we simply just go, well, we know that acceleration on Earth is 9.8. We've done that when we did kinematics, meters per second. We times it by the mass, that must be the force that the Earth is pulling down on us. And that's it. That's the weight force. All right. So what other forces are there?
Normal force.
Yeah. So we'll examine that now.